Alright, how you doing? Chapter 6, Machine Shop with Axles and Wheels. Axle, straight axle, the trim with the gauge with the special axle, lathe with the form, lathe with the ordinary form, with the head stack with the left hand, with the end with the proppet head, with the tail stack with the right, with the modest modern with the lathe is off the center drive, the type in which the axle, after it having been turned in the middle, is gripped. A, B, and C, and C, B, and A. Driven and support figure 23 straight axles. Okay, driven the supporting the tail stock with the HM, but the method of giving the more of the rigid supporting with the for the axle, then enable the cutting of the tool to be with the both ends. Figure 24 show with the lathe type of the which immediate the axle at 9 feet long with a straight axle. Illustrated figure 23 in which the AA are with the wheel seats with the IE with the portion with the which the wheel center of the press and then the PB or the journals revolve around the bearings of the axle box of the collar CC. Keeps the journal from the moving laterally. The wheel seats generally with the turn smoothly with the turn truly circular and journals are finished. Brushing rollers with the revolving seal with the rollers secured with the tool post with the carry with the attachment back with the lathe with the figure shown in figure 24. They're passed again with the revolving journals in part with the later with the perfectly even the polished surface of the grinding of the machinery is now frequently used with the axles more especially for the finishing of the wheel seats. Figure 24 shows the center driving axle lathe. Okay. Alright, crank axles return heavy lathe with the ordinary pattern with the position with the crank of the web that does not allow with the center drive with the inside with the face with the draw with the crank of the web slab with the out more usually mount with the out with the large revolving disc of the preferably over the number of the cutters inserted with the machine at the top of the shown figure 25 that has two centering the head stock with the back of the one relation for the hidden from the front from the view in which the crank axles have with a special chuck with this so allows the revolving the disc of the provided with the cutters ladder slowly feed with the crank between the cranker arm and the cup of the out of the dimension required with these parts of the work complete with the head stock of the set with the motion revolve the crank axles which is set with the crank pin round with the cutting of the tool with the circular form the axle is then turned round into the centering head stock and then the other crank arm is pulled and milled out with a pin in the turn. Many crank axles, large modern engines, instead of being forged in one piece, are now built in 9 pieces, 2 ends, and 1 middle. Figure 25 shows the crank sweep milling machine. Alright, pieces of 2 pieces for the crank pins, all above the circular form of the flat slab with the web of the slabs are milled round and vertically milling machine a hole with the pin with the part with the axle board they are heated with the shrunk with on the circular part with the crank pins of the axle finally screwed with the round plug with the screw with the joint with the directional parallel to the length of the axle. Your wheel century refers to the portion of the which with the include with the central board boss with the spoke with the rims with the bolt button does not include the axle tire with when wheel centuries are not generally made with the cast steel they are turned outside with the also board with the axle either the wheel lay at the more conveniently on the resolving table of the horizontal boring mill with the type shown in figure 26. Wheel centuries are found on the axle with the hydraulic press with the pressure required with being of the 60 to 120 tons with according to the side of the wheel. The axle, small bogey, the spokey, and tender wheel are pressed with the 60 tons, so above the large driven the wheel with requiring the 90 to 120 tons to obtain with the necessary grip of the part of the axle wheel with the seat wheel the face with the turn slightly larger than the board of the wheel. Century with the amount with the difference of allowance of the axle of 8 3/4 inch diameter about 21,000 of an inch with the hydraulic pressure with the required with about being 10 to 12 tons per inch diameter of the axle if the pressure is registered on the gauge with the recorded attached to the pressure. The pressure presses to small with the wheel with it taken off again with another substituted. In this case, the driven coupled wheel. The additional security is provided with the driven key with the keyways cut in the both wheel and axle, both in the case of the other wheels. And now keys are used. Figure 26 shows a horizontal turning and the boring milling. 27 shows the boring tyres of the horizontal boring. Tyres. The tyres, which come with a seal with the manufacturer rolled out without weld, they are bored inside of the internal diameter slightly less than the outside the diameter of the wheel century with onto which they have been shrunk allowing for being about 1,000 for the diameter of the wheel century. If the formerly tires were bored on the wheel with the layout is found much more convenient and expeditious. The more boring and turning mill type is shown in figure 26 for the type of the tyres are placed horizontally on a revolving table shown in figure 27. The tools are the tool holders. Shown in the special ones which allow the several tools to be used at once, all having been bored and tires are placed on the floor inside of the shallow pit, which have the circular gas ring around it with the shaft, and then are seated so that they expand the wheel centuries on the axle, so is then taken up to the crane and then lowered on the tire, which cools and shrinks and grips the wheel. Figure 28 and 29 show the tire fastening. Figure 28 and 29 show the most usual method of securing the tie reed wheel. The T section through the tie reed. The W is one through the rim of the wheel. The both example, the lip of the A prevents the tie reed from sliding laterally over the wheel rim towards the inside of the rail. The flange F that runs against the rail prevents the tie reed sliding towards the outside. In figure 28, the tie reed is secured by a set of screws S and which the passes through the rim of the wheel, and some of the engineers object to the set of the screws, then the tie reeds 10 break at the hole of the alternative of the construction. Figure 29, the tie reeds help with retaining the ring R, which is heated with the driven into the recessed groove shown, and the eyelet B of the tie reeds hammered down all around wheel of the ring out of the ring. The outside crank pins upon with the work with the coupling rods, also with the connection rod of the outside of the cylinder engine for the turned into then with the grinding machine that press into the holes and bores and the wheel bosses, and to receive them, a pin on the one side of the engine has to be fixed exactly 90 degrees with a pin with the opposite end of the boring of the holes in the wheel is done with a special quartering machine, which both holes and bored simultaneously. The opposite wheel arrangement of the machine is such at the 90-degree angle automatically maintained. Alright, finally, with the complete set of the wheel, the axles are lifted with a heavy wheel lathe, and the top of the shown figure 30, whether they have the tie reeds turned on the outside of the lathe, are very rigid and powerful. The machine since the extremely hard steel with the tie reeds plate from the heavy strength of both of the cutting the tools and machine. Figure 31 through 34 show the set of the sheet iron gauges used for the turning of the tie reeds. Figure 31 through 33 are used to see that the cone of the head of the tie reed is usually 1 in 20, and the height of the flange are correct. Figure 34 tests for the proper distance about part of the gauge of the two tie reeds on one pair of wheels. Our figure 30 shows the locomotive driving wheel lathe. Or wheel balancing. In some shop with the wheel with the furniture with the balance revolving around with the high-speed speed of a special machine and adding with a small belief they revolve with the perfect setting with his machine with the purpose designed by the Mr. J.J. Churchwood, chief mechanical engineer of the Great Western Railway, used in Swindon works. Illustrated figure 35. The wheels, figure 31, 32, and 33, and 34 type of tie reed gauges. The wheels are axle rest of the bearing supported with a spring for the hour, driven with a speed crystal spring of 60 miles an hour bearing that means of the 55 horsepower electrical motor. The speeds are registered with the counter on the wall at the back of the machine. The hand wheel that actuates the brake block with means of the screws so that the wheels can be stopped quickly when required after the current has been cut off. The excessive deficiency of the balance are found on the small weights of tests during the testing of the securely steady with the ready running afterwards rectified with the balance of the weights. Axle boxes. Or your axle box. The account of the work done in the wheel shop of the committee eventually include the axle box with the most frequently machine with the general machine shop with the butt. They have been fitted with the journals in some of the modern works of the machine with the wheel shop. They're closer to the tie reeds. They require to be taken from the one shop to do another. Alternate method used in other works to fit in the bed of the axle box with the short and dumb in the axle journal kept in the machine shop. For this purpose, the axle boxes have been taken straight to the direction shop. Axle boxes are either gunmetal cast steel with the fitted with a gunmetal with the bearing with the latter form of the being more the usual of the brasses, which bearing journal are provided with the recessed into the running of the white and the anti-friction metal consisting of about 80% of tin and 10% of the copper and 10% of the iron in the antimony. This prevents the journal and axle from being injured in the case of the bearing running top. The box and angle range and the planning of the machine, the two rows for the 10 burr boxes, each for the row planned between the jaws that receive the brasses and the axle boxes keeps which are machines returned and fitted with the box of the brasses must be fitted very carefully, where they must be well bedded down and to avoid any rocking action of the brass body box. The bowls are then broached out of the pin with the trigger with the keep it in the box, following with the box, and this in the box for the fix for the long plane casting angular plate bed plating machine. About 12 boxes, 6 on each side with the plane on one face, along with a recess at the side of the face of the horn blocks. The boxes are then reversed in the other face of the recess plane, where they are now bored 4 to 6 together on the special boring machine. In some cases, the boring of the facing of the done altogether, the double boring of the two boxes are being machined at once. One oil grooves, which are frequently chipped out with a chisel, are normally frequently grooved out on a small milling machine. Finally, the fitters are taking the boxes, bed brasses down on the journal and dummies by using red marking and filling down the eye spots. Alright, the figure 35 shows the wheel balancing machine. Figure 17, figure 7, over general machine shop.